Power series have many applications. They have a tendency to turn up in the analysis of phenomena that involve regular repetition. One useful and common application is computing present and future value of money. Because of the potential for compound interest, money can grow exponentially. Financial analysis gets complicated quickly, so it's no wonder that it's such a big industry. Full analysis takes into account risk, taxes, inflation, etc. Whether it's an unlikely lottery scenario or a more common investment or loan scenario, these problems all have something in common. At the core, they convert between present and future value of money. Let's see an example of this. A lottery is advertising a jackpot of $600 million. However, that is the total future value of money collected over 30 years. The lottery offers lump sum payment options, in this case $361 million. We want to find the interest rate the lottery is basing this calculation on. The rules for this lottery specify equal payments of $20 million per year. Under these conditions, the present value P sub 1 now equals 20 million divided by 1 plus R, the interest rate. Similarly, the present value P sub 2 is going to be 20 million over 1 plus R quantity squared. In general, we can say that the present value of a payment k years from now is equal to the payment divided by the quantity 1 plus r to the kth power. For this problem, this can be summed over a finite period of time using the sum from n equals 0 to k minus 1 of 20 million over the quantity 1 plus r to the n plus 1 power. Alternatively, we can calculate based on infinite time. The equation for perpetuity is the sum from n equals 0 to infinity of the payment c over 1 plus r to the n plus 1. We plug in our limits, n equals 0 to 29, for the sum of $20 million over 1 plus r to the n plus 1, and set this equal to the lump sum payment $361 million. Notice that this is similar to a basic geometric series, so we know it converges to 1 plus r over r. We also know that the present value P is equal to the payment C over the interest rate R. We know that the payment is 20 million, and we know that P is 600 million, so we have 600 million equals 20 million over R. This gives us a rate of about 0.0333 or 3.33%. This is a pretty conservative interest rate indicative of relatively safe investments. Let's say you'd like to try investing for a net gain of 8% interest. Which deal would you prefer? Deal 1 is that you'd receive $20,000 every year for 8 years. Deal 2 is that you'd receive, or rather retain, $120,000. We calculate the present value of deal number 1 as $115,000, which is slightly less than deal 2. Therefore, the second option is better unless other factors like risk and taxes come into play.